Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 7 hard practice problems involving fractions. As a matter of fact, most of these problems have come from the comments section of my videos over the course of the past 2 months. So in light of that, I ask that you treat this video like a mini ASVAB practice test, and correspondingly, that means you should pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB. So as you work your way through these practice problems, try not to make use of any of those resources. Finally, I want to mention that in the description of this video, I'm going to include timestamps that will be associated with each question. Next to the timestamp, of course, will be the topic that the question's testing, as well as a link to video where you can learn more about that topic. So all that being said, let's go ahead and get started with today's video. All right, so as you can see, number 1 says, using 22 over 7 to approximate pi, find the area of a circle that has a diameter of 4/5 centimeters. Express your answer as a fraction. All right, so clearly for this problem, we're going to have to find the area of a circle. And you should know that there's only one formula to find the area of a circle. Notably, area is equal to pi r squared, where r refers to radius. The problem with this question is it gave us the diameter of this circle. Notably, it's a diameter, or d, is equal to 4/5. Clearly, we need r, not d, to continue our work. So you have to understand that as far as circles are concerned, there is a relationship between the diameter and radius of a circle. Notably, a diameter is always twice as long as a radius, and we can express that algebraically as d equals 2r. Well, as it happens, we know what d is, so let's go ahead and plug in 4/5 for d in this equation. So we have 4/5 equals 2r. And clearly, if we solve for r, we'll be able to take that value, plug it in over here, and ultimately find the area of our circle. So let's divide both sides by 2 now. This will cross out here, leaving you with just r on this side. And right here is where most people would probably get stuck. We have 4/5 divided by 2. Well, technically, any whole number can be expressed as a fraction by placing it over 1. So I can express 2 as a fraction by placing it over 1. And now let's take a look at what we have here off to the side. We have 4/5 divided by 2 over 1. That is to say, we're now dividing 2 fractions. And you should know that when you divide 2 fractions, you follow the algorithm keep, change, flip. This means you keep your fraction in the numerator the same. So we're going to keep 4/5 as is. We're going to change from division to multiplication. Again, this is a division bar. We're going to change that to multiplication. And then we're going to flip our second fraction in the denominator. So instead of being 2 over 1, it's going to be 1 over 2. And you should know that when you multiply 2 fractions, you simply multiply straight across. So this is going to become 4 times 1 over 5 times 2. 4 times 1, of course, is 4. And 5 times 2, of course, is 10. It should be pretty obvious that you can actually reduce this by dividing both 4 and 10 by a common factor of 2. 4 divided by 2 is 2, of course, and 10 divided by 2 is 5, of course. So we can see that our r is 2/5, and let me go ahead and write that down here. Our radius in this case, is 2/5. So if we have a diameter of 4/5, our radius is going to be 2/5. And now that we know what our radius is, we can come back to this area formula and plug in 2/5 for r. So this becomes area equals, and let's go ahead and substitute 22 over 7 in for pi. Again, the problem told us to do that. So this will become 22 over 7. We now know what our radius is. It's 2/5, and that's going to be squared. So now all we have to do is solve 22 over 7 times 2/5 squared. Well, according to the order of operations, which you can remember using the acronym PEMDAS, P, of course, stands for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. According to PEMDAS, we're going to work out our exponents before we work out our multiplication. And in this case, we have 22 over 7 times, that's multiplication, 2/5 squared. That squared is an exponent. So we're going to do our exponent first, and then multiplication after that. Let me come down here so it's easier to see. Here's another place where a lot of people would get stuck. We have 2/5 squared, and let's pull that off to the side to see how we're going to work on that. We have 2/5 squared. Well, when you square a fraction, you actually apply the square to both the numerator and denominator separately. So this becomes 2 squared over 5 squared. 2 squared, of course, is 4. 5 squared, of course, is 25. So 2/5 squared is the same thing as 2 squared over 5 squared, which is ultimately 4 over 25. So now this becomes 22 over 7 times 4 over 25. And again, we're just multiplying two fractions here. So all we're going to do is multiply straight across. That is to say, this is going to become 22 times 4 over 7 times 25. And if it's helpful, you can work both of these off to the side. We have 22, my pen's starting to act up here. We have 22 times 4. 2 times 4 is 8. 2 times 4 is 8, so that's 88 in our numerator over, what's 7 times 25? You should know that 6 times 25 is going to be 150. Therefore, 7 times 25 is going to be 175. That said, let's work it off to the side just to verify we did it correctly. 25 times 7. 5 times 7 is 35. Drop down a 5, carry a 3. 2 times 7 is 14, 15, 16, 17. Okay, so we can see that this becomes 88 over 175. Our units was centimeters, so let's tack those back on. And whenever you find the area of something, your units are always going to be squared. I do not believe we can reduce this fraction, so the answer to this one is D, 88 over 175 centimeters squared. Again, it's not uncommon for the ASVAB to give you a very simple problem that requires you to do a lot of arithmetic reasoning. In this case, a lot of reasoning with fractions in order to get your answer. So make sure you can work out problems like this one. All right, so that's number one. Pretty difficult problem to start this video. All right, so number 2 says, how many 10-pound bags of peaches can be made from 800 peaches if each peach weighs 1/4 pound? All right, so at first glance, this problem seems pretty simple. But that said, again, we're going to be working with fractions in this case. And to start, you should reframe this question by asking yourself this. How many pounds does 800 peaches weigh if each peach weighs 1/4 pound? Well, that's pretty simple to figure out. Again, how many pounds do 800 peaches weigh if each peach weighs 1/4 pound? Well, that's going to be 800. That's our 800 peaches times 1/4. All right. So in this case, we're multiplying a whole number, notably 800, by a fraction, notably 1/4. As we've seen in this video already, we can write 800 as a fraction by placing it over 1. And now we can just go ahead and, as we normally would when we multiply fractions, multiply straight across, such that this becomes 800 times 1 over 1 times 4. Of course, anything times 1 is itself, so 800 times 1 is 800. 1 times 4 is just 4. And you should be able to do this math mentally. What is uh, 8 divided by 4? We should know that's 2, and all we have to do is tack on our 2 zeros. So in other words, our 800 peaches weigh 200 pounds. Now this question's much simpler. If we have 200 pounds of peaches, how many 10-pound bags can we make from that 200 pounds? Clearly, that's going to be 200 divided by 10. All right, so we are dividing 200 by 10. If you want to do this quickly, you can cross out a pair of these corresponding zeros in the numerator and denominator. This becomes 20 over 1. Anything divided by 1 is itself, so this will be 20. In other words, if you have 800 peaches and they each weigh a quarter of a pound, that means you can make 20 10-pound bags of peaches. And that means the correct answer in this case is C. All right, so nothing too difficult there. All right, so as you can see, number 3 says a train goes 3 times as fast downhill as it can go uphill, and 2/3 as fast uphill as it can go on level ground. If it goes 100 miles per hour downhill, how long will it take to travel 60 miles on level ground? All right, so this problem, in my personal opinion, is very difficult because it combines two somewhat difficult concepts into one question. Notably, it combines fractions as well as the distance formula into one problem. And you should recognize immediately that this question has all the variables in the distance formula. Again, the distance formula describes the relationship between distance, rate, and time. Specifically, it says distance, or d, is equal to rate times time, that is r times t. And if we look right here, we can see it says, if the train goes 100 miles per hour downhill. Well, what is 100 miles per hour? That is a rate. How long will it take? Well, how long is referring to time, so that's a t, to travel 60 miles on level ground. 60 miles is a distance. So let's start plugging these things into our distance formula. Again, we know the distance that this train is going to travel is going to be 60 miles. So in place of d here, we'll put 60. Now, the difficult part of the problem is right here. We were given a rate of the train as it goes downhill, but we want to know how far it's going to travel across level ground. So we're going to have to convert this rate here to be in terms of a speed across level ground. So I'm going to put an asterisk next to this r to remind myself I need to make a conversion there. And of course, we're going to be solving this question for t, how long. So ultimately, when everything else is said and done, our answer is going to look like this. T, our time equals. So that's our goal. All right, so let's work on converting this rate that was given in terms of going downhill to be a rate in terms of going across level ground. So again, this train has 3 different rates. It has a rate when it goes across level ground. It has a rate when it's going uphill. And it has a rate when it's going downhill. All right, and if we look at the first part of this question, it says a train goes 3 times as fast downhill as it can go uphill, and 2/3 as fast uphill as it can go on level ground. So I'm going to start with this level ground. We don't know how fast this train goes across level ground, so I'm going to call that x. That is to say, I'm going to say this train goes x miles per hour across level ground. And if we work backwards, we can now say this. The train goes 2/3 as fast uphill as it can go on level ground. Well, if it goes x miles per hour across level ground, then we know it goes 2/3 of x miles per hour uphill. And then finally, we can use this to figure out how fast it goes downhill. Again, it goes 3 times as fast downhill as it can go uphill. Well, we know it goes 2/3 x miles per hour uphill, and we'll multiply that by 3. All right, so let's go ahead and reduce this right here. We have 3 times 2 over 3x. If I write this 3 as a 1, we can go ahead and quickly simplify this. I can say 3 goes into 3 one time, 3 goes into 3 one time. So this becomes 2 over 1x, and 2 divided by 1 is just 2, so that's 2x. So here are our rates. We have x, which is an unknown, 2/3 x, and 2x. Well, we know that this train goes 100 miles per hour downhill. So we know 2x equals 100. And if we divide both sides by 2, we can actually solve for x. So this crosses out here, leaving you with x. 100 divided by 2 is 50. Well, when we solve for x, what did we figure out? We figured this out. We figured out the speed of the train as it goes across level ground. And that's what we need to plug into this formula. So now we have 60 equals 50t. And now we're just solving for t, so let's divide both sides by 50. This crosses out here, leaving you with just t on this side. And you can see that t is 60 over 50. Let's go ahead and cross out these corresponding zeros. This becomes t equals 6 over 5. Well, as you can see, our time is given in terms of hours and minutes. So we're going to have to convert this 6/5 to be in terms of hours and minutes. And what you can do is you can treat this as long division. You can say this is 6 divided by 5. And now we can go ahead and work this out. We can say 5 goes into 6 one time without going over. 5 times 1 is 5. 6 minus 5 is 1. All right, to proceed, we're going to add a decimal here and a 0 placeholder. We're going to bring down this 0, and we're going to take our decimal and bring it up into our answer. 5 goes into 10 2 times. 5 times 2 is 10, so there's no remainder. In other words, it takes this train 6/5 of an hour, or 1.2 hours, to go 60 miles across level ground. Of course, that isn't an answer choice. So now we have to figure out what 0.2 of an hour is. Well, there are 60 minutes in an hour. And we're trying to figure out what 0.2 of 60 minutes is. So we can do 60 times 0.2. Again, we're multiplying a whole number by a decimal. So we're going to shift this decimal one time to the right, such that this becomes 60 times 2. And when we work this out, we'll take our one decimal and shift it back into the left. 0 times 2 is 0. 6 times 2 is 12. Bring our one decimal back in. And we can see that 0.2 of an hour is going to be 12 minutes. So this is 1 hour and 12 minutes. So our answer to this one, of course, is A, 1 hour and 12 minutes. All right, so as you can see, number 4 says, it takes 6 small glasses to make a quart. If a glass is a quarter filled, what part of a quart is in the glass? And let me just say this. This says glasses, not cups. So a glass can come in a variety of shapes and sizes. So this is not a conversion problem. Again, if this said cups, we would be talking about a conversion problem, but since it doesn't, we're going to have to take a different approach to solving this one. And the approach we're going to take is this. We're going to set up a proportion to figure this one out. And again, we're comparing two things in this question. 6 glasses to make a quart. A quarter of a glass fills up what part of a quart? So we're comparing this with this over here. All right. And the way you fill in proportions is like this. You take the information from the word problem that's given, and you fill that in on the left-hand side of the equal sign. Then you take the information you're trying to figure out, and you fill that in on the right-hand side of the equal sign. Well, what information is given? This problem told us right here, 6 small glasses make a quart. So I'm going to write this, 6 glasses make 1 quart. Okay? And what are we trying to figure out? If a glass is a quarter filled, what part of a quart is in the glass? Well, again, this says the glass is a quarter filled, so that's a quarter of a glass, is equivalent to what part, or x part of a quart. And you may have noticed that across this equals sign, I kept my units the same. I had glasses in the numerator over here, so I'm going to keep glasses in the numerator over here. I had quarts in the denominator over here, so I'm going to keep quarts in the denominator over here. Now that we've set up our proportion correctly, let's go ahead and proceed by doing some cross multiplication. This becomes 6 times x, which is 6x, equals 1 times 1/4. Again, anything times 1 is itself, so 1 times 1/4 is just 1/4. All right, so clearly if we solve for x, we'll be able to answer this question. So our next step is to divide both sides by 6. This will cross out here, leaving you with x on this side. And we've seen this already in this video. We have 1/4 divided by 6. Again, we can write 6, a whole number, as a fraction by placing it over 1. And now we have the division of two fractions, notably 1/4 divided by 6 over 1. And let's work this off to the side. We have 1/4 divided by 6 over 1. Of course, we're going to use the algorithm keep, change, flip to figure this out. Of course, k, or keep, refers to this fraction in the numerator. We're going to keep that as is, so that's going to be 1/4. We're going to change from division to multiplication, and then we're going to flip this fraction in the denominator. So instead of being 6 over 1, it's going to be 1 over 6. And again, when you multiply fractions, you just multiply straight across. So this becomes 1 times 1 over 4 times 6. 1 times 1 is 1. 4 times 6 is 24. So clearly, if you have a quarter of a glass, that means there's 1/24 of a quart in that glass, and the answer is D. All right, so again, make sure you know how to work with ratios, rates, and proportions. Those show up frequently on the test. All right, so as we can see, number 5 says a television show is 60 minutes long. During the show, there are 8 1 1/8 minute commercials. Approximately what percentage of the show is a commercial? All right, so the first thing we have to do is add up the total length of these commercials. Again, there are 8 commercials, and they each run 1 1/8 minutes long. So we have 1 1/8. That's our first commercial, plus 1 1/8. That's our second commercial, third commercial, fourth commercial, fifth commercial, sixth commercial, seventh commercial, and eighth commercial. All right, so by the way, you could have also done one, or you could have done, by the way, you could have also done 1 1/8 times 8. In fact, that's how most people would probably work this out, but I'm going to work it out this way in order to show you what's going on in this problem. So as you can see, if you were to add all these mixed numbers together, that would be very slow and tedious. Of course, there must be a way that you can do this math very quickly, and there is. You can separate the 1s and the 1/8. So again, we have 8 ones. That's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 minutes of commercials right there. And then what about these 1/8? How are we going to add those together? Well, let's think about that up here. We have 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. How many is that? That's 1, 2, 3, 4, 5, 6 plus 1/8 plus 1/8. All right, when you add fractions, what you actually do is you keep your denominator the same, and then you add everything in your numerator. So that's 1, 2, 3, 4, 5, 6, 7, 8. So this becomes 8 over 8, which is just 1. So this becomes 8 minutes plus 1 minute, which means there's a total of 9 minutes of commercial time. All right, so now that we figured out our 8 commercials are 9 minutes long in total. We want to figure out what percentage of a TV show that is. So that's going to be 9, the length of our commercials, divided by 60, the length of our TV show. And of course, we're going to be converting this fraction into a decimal, and then it's very easy to convert a decimal to be a percent. All right, so let's work on doing that. How do you convert fractions to decimals? You actually read this as long division. So I'm going to read this, and let me move down a little bit. I'm going to read this as 9 divided by 60. And of course, when we do long division, we start by asking ourselves this: how many times does 60 go into 9 without going over? It doesn't. So I actually have to add a decimal here and a couple of 0 placeholders in case I need them. Once I add my decimal, I bring it up into my answer, and now I can disregard the decimal down here. And again, we said 60 did not go into 9, so let's put a 0 above the 9. And let's move on. Now we're going to ask ourselves, how many times does 60 go into 90 without going over? Of course, that's going to be 1 time. 60 times 1 is 60. 90 minus 60 is 30. And now we get to drop down one of our 0 placeholders. And the question becomes this: how many times does 60 go into 300? Well, what is 6 times 5? 6 times 5 is 30. Therefore, 60 times 5 will be 300. 300 minus 300 is 0. So we can stop. We don't need this extra placeholder. So we know 9 over 60 is 0.15. And of course, many of you would know that 0.15 is the same thing as 15%. But if you didn't know how to convert a decimal to a percent, you would have to do this. You take 0.15 and you multiply it by 100. Again, when you multiply a decimal by a power of 10, such as 10, 100, 1000, 10,000, and so on, you take your decimal place and you shift it to the right according to how many zeros there are in the power of 10. In 100, there are 2 zeros, so we're going to shift this 1 2 times to the right, and this becomes 15%. All right, so number 6 says, in an auditorium during an assembly, 1/6 of the students are 5th graders, 1/3 are 4th graders, 1/4 are 3rd graders, and the rest of the students are 2nd graders. If there are 96 students in the auditorium, how many 2nd graders are there? So for this one, it's a little bit difficult to see at first, but we know that the auditorium contains 1 out of 1 are 100% of the students. So I'm going to represent the number of students in the auditorium with a 1 here. And then we know 1/6 of the students are 5th graders. So let's subtract 1/6 from that 1. 1/3 are 4th graders. So let's subtract 1/4. And 1/4 are 3rd graders. And by doing this subtraction, we'll figure out how many students are 2nd graders, because we're taking 1, the total student population, we're subtracting out the 5th, 4th, and 3rd graders, which will leave us with the number of 2nd graders left. All right, so let's go ahead and work on this. Again, we're subtracting fractions from a whole number. So what you can do is you could rewrite this like this: 1 over 1 minus 1 over 6 minus 1 over 3 minus 1 over 4. That is to say, you can express this whole number of 1 as a fraction by placing it over 1. And now, in order to add and subtract fractions, your denominators all have to be the same. As you can see, we have a denominator of 1, 6, 3, and 4. So we're going to have to rewrite either 1, 2, 3, or all of these fractions such that they have the same denominators. And what is going to be the common denominator between 1, 6, 3, and 4? That is, what number do all these go into? They all go into 12. So we'll go ahead and rewrite all of these such that they have a denominator of 12. To write 1 as 12, I have to multiply it by 12, and I'm also going to have to do that to its numerator. 12 times 1 is 12. 12 times 1 is 12. So 1, which is the same thing as 1 over 1, is the same thing as 12 over 12. To write 6 as 12, I would have to multiply it by 2, and I'm also going to do that to its numerator. 6 times 2 is 12, 1 times 2 is 2. To write 3 as 12, I have to multiply it by 4, and I'll also have to do that to its numerator. 3 times 4 is 12, 1 times 4 is 4. To write 4 as 12, I would have to multiply it by 3, and I'm also going to have to do that to its numerator. 4 times 3 is 12, 1 times 3 is 3. All right, so now that these fractions all have the same denominators, we can combine them like this. Again, they're all going to be over 12, and this will become 12 minus 2 minus 4 minus 3. And we can actually make this a little bit easier. This will become this. 12 minus 2 plus 4 is 6, 7, 8, 9. All right, so this is 12 minus 9 over 12. 12 minus 9, that's 9, 10, 11, 12. That's 3 over 12. And we should know that we can reduce 3 over 12 by dividing the numerator and denominator by a common factor of 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So this means that 1/4 of the students in the auditorium are second graders. All right. And we got to figure out how many students that actually is. So we're going to take the 96 of the students in the auditorium and we're going to multiply that by 1/4. All right, so now we're multiplying a fraction by a whole number, notably 1/4 by 96. Let's write 96 as a fraction by placing it over 1. And when you multiply two fractions, you just multiply straight across. So this becomes 96 times 1 over 4 times 1. Anything times 1 is itself, so this becomes 96 over 4. And now we can actually do this long division. What is 96 divided by 4? Well, 4 goes into 9, 2 times without going over. 4 times 2 is 8. 9 minus 8 is 1. Drop down this 6. 4 goes into 16. 4 times, given that 4 times 4 is 16. 16 minus 16 is 0. So this becomes 24. In other words, 1/4 of the students are in second grade, which means that 24 of the 96 students are in second grade, and we can see that that is answer choice A. All right, so as we can see, number 7 says find the product of the reciprocals of 1/4, 6, and 1 1/2. All right, so in case you didn't know it, the reciprocal of a fraction is basically a fraction inverted. So let's say we had the fraction 1/3 and I asked you to find its reciprocal. Its reciprocal is going to be this. We're going to take this 3 and move it to the numerator. We're going to take this 1 and move it to the denominator. So you basically exchange your numerators and denominators. So before we can find the product of these reciprocals, we actually have to figure out what the reciprocals of these are. So we have 1/4, 6, and 1 1/2. Well, this one's actually very easy to do. The reciprocal of 1/4 is going to be 4 over 1, and I'm going to put a box around that to indicate that that is the reciprocal. What about 6? Well, we can express 6 as a fraction by placing it over 1. And what is its reciprocal? Again, we're just exchanging our numerator and denominator. That's going to be 1/6. Let's put a box around it to remind ourselves that that is the reciprocal of 6. And what about this mixed number 1 1/2? Well, let's convert this mixed number to an improper fraction. To do that, we're going to do 1 times 2, which is 2 plus 1. So that's going to be 3 over 2. Now we can quickly figure out what its reciprocal is. Again, we're just exchanging our numerator and denominator. So this is going to be 2 over 3. Let's put a box around that. All right, so we found our reciprocals. Now we got to find the products of our reciprocals. Product means to multiply, so we're going to do 4 over 1 times 1 over 6 times 2 over 3. And again, when you multiply fractions, you just multiply straight across. So this becomes 4 times 1 times 2 over 1 times 6 times 3. 4 times 1 is 4 times 2 is 8. 1 times 6 is 6 times 3 is 18. And it should be pretty obvious that we can actually reduce this by dividing our numerator and denominator by a common factor of 2. 8 divided by 2 is 4, and 18 divided by 2 is 9. So the product of these reciprocals of 1/4, 6, and 1 1/2 is going to be 4/9. All right, so that's that one. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. While these questions may seem difficult at first glance, they are not that difficult as long as you understand how to add, subtract, multiply, and divide fractions. So make sure you can perform those operations with fractions. And let me just say this, if you want to help my channel out, please consider subscribing to it. I always appreciate that very much. And on that note, I'm going to go ahead and cut you loose.